From the Cube studios in Palo Alto and Boston, bringing you data-driven insights from the Cube and ETR. This is Breaking Analysis with Dave Vellante.
Last November, we argued that Jamie Dimon is sitting on a treasure trove of proprietary data that will never find its way into proprietary LLMs via the internet. And as such, he was Sam Altman's biggest competitor because his data is more valuable than the democratized insights from these LLMs. Now, our premise was at the time and continues to be that foundation model companies are waging an internecine battle chasing artificial general intelligence, what we called Messiah AGI, and the true holy grail is what we called enterprise AGI, meaning applying AI to proprietary data inside of enterprises will ultimately prove to be the most valuable endeavor. Now today, we extend that argument and posit that agents and enterprise digital twins, powered of course by data, will drive the next wave of AI value. Hello and welcome to this week's theCUBE Research Insights powered by ETR. In our previous episode, we set a framework for the why. In this breaking analysis, George Gilbert and I explain how enterprises like JPMC will drive value in the AI era in a way that frontier model vendors, we think, cannot. We'll examine our original premise and share data that further reinforces the challenges that foundation model vendors face, and moreover, we'll explain why agents programmed by data will ultimately provide the biggest value unlock for enterprises in the coming years. Hello, George, good to see you. We got a lot of ground to cover, so let's get into it.
Right, all right, we've got a ton of stuff to go over now to extend what we said last November and to start talking about the mechanism.
All right, so we're going to talk first about the three waves of agents. So think of the agent evolution in three distinct sort of waves or S-curves. You know, consumer agents like ChatGPT. GPT-5 is ultimately what we think is going to deliver the first true consumer grade model, not just chat. You got post-training in the middle, agents like Anthropic's Claude, which paired up with Cursor. We're going to talk about that. And then you got enterprise agents. And this is the next frontier that really is the fundamental underpinning of today's episode. These are agents powered by a live digital twin of the business. And we're going to talk about that today. We're not talking about digital twins of a factory like Jensen's Omniverse, but rather of an enterprise. And so the value really, we think, is so large that even Jamie Dimon with that giant balance sheet is going to sort of step into the realm of what we have considered Sam Altman's playing field. So George, with that framing, walk us through why the jump from consumer and sort of coder agents to enterprise agents, it's not like linear extrapolation. What are the new technologies and other things that bring us to this concept, this metaphor we're using about Jamie Dimon and competing with Sam Altman?
Well, Jamie Dimon, as we've talked about before, is a proxy for enterprises and the proprietary data and know-how that they have within their four walls that LLMs cannot train on, that frontier LLMs cannot train on. This is why the real value will come from enterprises applying that data and know-how to extending the frontier LLMs or models that are similar to that. And we'll explain why. But the real revolution is that we've moved from scaling laws in the pre-training era, which is the GPT models that ChatGPT and similar products were built on, to the post-training era, which is where we start using reinforcement learning. Reinforcement learning is a fancy term for trial and error learning. And for trial and error, you have to be able to learn from your mistakes. And it first works with software engineering agents, coding agents, because you can do things with code that tell you whether the thing actually works. Like you can run a test and see if it works. You can compile it. There are multiple things you can do to get feedback, and it fits into a programmer's workflow without huge changes. So that's where agents in the enterprise first take off. And then our contention is that to go beyond that is where we're going to need a new type of technology platform, the enterprise digital twin. And to get real value out of that, we're going to have to go with a new, not just new technology model at the foundation where the data is, but a new operations model where firms have to organize around end-to-end outcomes, like onboarding a new customer, not departmental or functional specialization. And then for vendors who are going to help these customers, they have to provide end-to-end process-centric data platforms or digital twins. It's not the conventional data platforms or the siloed applications. And just as important, the model vendors, it appears, we're going to need open weight models for this trial and error learning to work properly. And that's incompatible with the frontier model vendors' business models. So we're going to need lots of changes. And the main point was that Jamie Dimon and the value he's going to extract from this era of AI is going to need a completely different scaffolding and set of business models for customers like him, as well as the vendors that supply him, compared to the era where ChatGPT is creating and capturing value today.
All right, that's a good setup, almost like a good TLDR. But let's double click into wave one, the consumer agents. So we know ChatGPT got it all started. But with GPT-5 is where we think this is going to be an inflection point and where the real value begins for true consumer agents. You can see the projections of OpenAI's revenue. I mean, it's just, insane, low single, billions today, upwards of 50 billion in 2027. That a lot of people think that threatens Google search. We'll see. But, the red callouts there are instructive, George. Explain the caveats and, you mentioned sort of technical rewiring and sort of different economic incentives that got to fall into place before GPT-5 class agents can move from, what a lot of people feel like is a useful but kind of cool demo to a true digital assistance. How do you see that playing out?
Well, remember that, when the internet took off 30 years ago, like John Doerr famously said, this is the greatest legal creation of wealth in the history of mankind. And you hear similar statements now, like this is the greatest technological advance, since fire or the wheel or, electricity. And yes, it may well be, but there has to be huge disruptive changes for this to happen. And I do believe we give credit where it's due that ChatGPT on GPT-5 is probably going to be a blockbuster because they are going to unify, the reasoning models, voice interaction, video, all the modalities, all the tools, deep research, computer use. Anyway, it's going to be this unified capability that's all wrapped up in what makes now the ultimate consumer agent, but it needs more than that to really take off. For instance, right now, the web is designed for humans. And yes, there are web crawlers, but they're indexing those pages so that they can serve them up for humans to read. But we have to rewrite all that so that it's readable and navigatable by agents. And you're seeing people come up with proposals for microtransactions so agents can read individual articles, say. And we need new security and payment rails. Anyway, there's the technical infrastructure that needs to change for the web itself. There's business models that need to be reinvented for publishers and e-commerce sites where there's going to be agent intermediaries. In other words, just the way 30 years ago, we got way ahead of ourselves in terms of how exciting the changes were going to be. We still needed to build out the business models and the broadband infrastructure. There's still a lot of work to do here. Like publishers need to go from search engine optimization to agent engine optimization. The e-commerce sites need to make their catalogs readable by agents. They need to market to agents. There's just a ton of work to be done. But I do not mean to take away at all from the huge promise of GPT-5. I just think that that is has huge consumer promise, but it faces challenges, and as we're going to lay out, there are other challenges to success in the enterprise.
So we can't really have this conversation without exploring the cost to train these models and the progress that they're making. So we all are excited about GPT-5, but let's take a look at the brutal economics of scale. And this chart you did tells the story. You've got this log scaling law line, and you got compute on the x-axis and test loss on the y-axis. So that keeps sloping down. But every bit of improvement means an order of magnitude jump in petaflop days, PF days of compute. So I like how you did the bubbles here. In the training costs leap is 35 million for GPT-3, 400 million for GPT-4, roughly 2 billion for GPT-5 is the estimate. So extrapolate out 10 billion for 6, and like jaw-dropping 50 billion for GPT-7, just to keep that curve bending. So this is where Messiah AGI meets the economic reality. So why do costs explode this way, and will techniques like RLHF or other techniques help flatten that curve? How do you see these companies moving forward?
Okay, so let's just unpack this where we got these numbers. I think the 35 million for GPT-3 class is kind of well known. That we know that for each generation there's a 10 to 30x increase in the training flops, but then with algorithmic efficiencies and with hardware efficiencies, you get something like it comes down to roughly maybe 5 to 10x growth in total cost per generation. And the reason these numbers might seem larger than expected is sometimes people just calculate the final training run. That's what was so confusing about the DeepSeek number at 6 million. But when you add in all the research runs and the experimentation, what's called data ablation, like you don't take that last 3-month or 2-month training run until you've done something like 3 to 10 times as much work leading up to it. That's why the numbers are so much bigger all in. And the point of this slide is that to get that incremental improvement in the model, what's called test loss is really just the model accuracy and its ability to predict, which comes out in terms of its reliability and also its ability to pick up more subtle patterns when you want it to synthesize and ask questions. But the point is the training cost growing like at this rate of 5 to 10x per generation is getting us incremental gains on pre-training. Now that doesn't mean that's the end of the story, but it means that just the cost of keeping up in pre-training is going through the roof. And as we're going to see, we're going to hit bottlenecks in training data, and in also with so many people piling into the game, potentially in the magnitude and durability of the price differentiation, at least for the underlying API. And we'll get into techniques where you can differentiate beyond the underlying API. But in other words, when the cost of when the cost is like 10 billion for the underlying model, as the next generation may well be, it's not going to support that many players, unless they have an extremely differentiated product that sits on top, which is what we're going to talk about.
Yeah, in our last Jamie Dimon episode, our first the one that we did last fall, we talked about hitting a data wall and how eventually synthetic data is not going to, it's going to be scarce and it's not going to give the same value that JPMC, for instance, and enterprise data have because synthetic data just can't replicate it. And we've been focused on compute costs, but there's another constraint which we're talking about now, which is that running out of free, high-quality human text. So this chart here tracks the effective stock, it's called, the inventory of usable internet tokens, which is that green band, versus the projected size of the data sets that are consumed by frontier models, that's the blue band. And those two curves, they merged in kind of 27, 28, meaning that every extra point of model improvement is going to either need paid data or synthetic data or some kind of new training tricks. And so, George, what are some examples of how this is playing out in the market? Maybe take us through the implications of this scarcity, and look how Meta is behaving is probably the best example.
Yeah, we should point out though that synthetic data, like it's easy to generate synthetic data with computer code because you can test it, and therefore the synthetic data now has more signal in it. Like, does it work? Does it not work? Or you have all sorts of tests. And that's why, as we'll see, coding agents take off first. But the first way of trying to get past this data wall, as we're going to show, is to use sort of human-generated reasoning traces, which is when you get essentially a wide range of experts in different fields to try and elaborate on their problem-solving strategies to get to a solution for how to solve problems in specific domains. And that's super expensive, as we're going to explain.
Okay, so as I sort of referenced, Meta reportedly shelled out about $15 billion to get 50% of stake in this sort of capability to bring in-house. Alex Wang of Scale AI says the next breakthroughs hinge on human annotated chains of thought, not just more scraped prose. So, and that annotation in depth is expensive, and so once that free, well dries up, there potentially will be problems. So we in our first Jamie Dimon video, George, you introduced the Alex Wang conversation. So since we've referenced that here, why don't we take a listen, play the video, and we'll come back and talk about it. Play the clip, please.
I mean, I think it really is data production is very similar to spice production. It will be the lifeblood of all the future of these AI systems. So I think best and brightest people is one key source. Proprietary data is definitely a very important source as well. Crazy stat, but JPMorgan's proprietary data set is 150 petabytes of data. GPT-4 is trained on less than 1 petabyte of data. So there's clearly so much data that exists within enterprises and governments that is proprietary data that can be used for training incredibly powerful AI systems. And then I think there's this key question of what's the future of synthetic data and how synthetic data needs to emerge. And our perspective is that the critical thing is what we call hybrid human AI synthetic data. So how can you build hybrid human AI systems such that AI are doing a lot of the heavy lifting, but human experts and people, the basically best and brightest, the smartest people, the sort of best at reasoning can contribute all of their insight and capability to ensure that you produce data that's of extremely high quality, of high fidelity, to ultimately fuel the future of these models.
George, Alex said data production will be the lifeblood of future AI systems, and he emphasized the human element. Is this why Meta paid $15 billion to essentially acquire Alex?
Yes, Alex and a few of his people. It was, and the network that Scale AI has for getting data labelers, trying to get experts in different fields. The reason we're highlighting this is even more than we suspected last November. Getting those human expert reasoning traces is sort of now the new bottleneck for these, frontier labs. And just, to kind of make a joke out of it, like if you squint, he's sort of saying we need these patriotic data contributions, so that the rest of us can benefit. And, as we're gonna explain, that sounds awfully like some historical figure said in the past. Um, it sounds an awful lot like what we call training data communism.
Yeah, we'll talk about that. So let's focus on how reinforcement learning and domain expertise could help get beyond this data wall. So we've established that free internet data is going to eventually hit a wall. So this slide takes the argument to its logical next step, which is kind of a slightly ironic extreme. You got Karl Marx on the left, and then Alex on the right, and he's like, George, to your point, he's history's richest communist after that acquisition or acquihire. So that's kind of the tongue-in-cheek headline that you've got to hear, from each according to his ability to each according to his needs. So pick it up, walk us through how this data communism model alters the bargaining power in AI. Who pays, who makes out?
It was just that it was trying to make a joke out of this notion that he's saying that we need to get the brightest people in each field to contribute their reasoning traces, so that the rest of us can train these models and get the benefit, and then those of us who use the models can get the benefit of their reasoning. And it almost sounded, again, to me like from each according to his ability, to each according to his need, which is why we made a joke out of comparing it to Karl Marx. It's like and so that makes Alex Wang history's richest communist.
So let's talk about coding, if we can, for a minute. It's one of the most popular use cases. I mean, we talked about consumer assistance, the challenges that they may face in hitting the wall. We've done this in previous episodes as well. We showed Magellan sailing off the globe, but there really is this area where agents are already driving revenue. You can see here this graphic. The face at the top is Dario Amodi, who's Claude model powers Cursor, which is the dev-centric sort of platform and assistance. It's gone from 0 to $500 million in ARR in a very short time frame. And we've got that same intelligence curve here on the vertical axis. And so the revenue table on the left really just is quite astounding. Take it from here, George. What makes coding so uniquely suited for early enterprise agent success? And we'll talk more about how that's going to apply potentially more broadly.
Okay, so that's the key. You identified the key, which is that it takes off because this is the first agent where we can apply trial and error learning, where the agent doesn't need 15 trillion tokens. It needs data that it can generate and then it can test. And when it passes the test or fails the test, it learns from that. This is called reinforcement learning. The layman's way of explaining it is trial and error learning. And the reason it takes off first is, one, you actually don't need a lot of proprietary data. The model generates the data in the sense that it'll try a solution. So that's synthetic data, and then it can test it in a number of different ways to see if it works. And it fits naturally into existing developer workflows. So that's why coding agents or software engineering agents have taken off first. As you pointed out, Cursor is only the iconic example. There are many, many others that have taken off. And we put Dario Amodei and Anthropic, in there as well, because his frontier model is the one that is the favored model for these coding agents. Now, the idea, one thing we should point out, though, is that most of them today are building net new code. They're not really refactoring old code. They might translate old code, but they're not refactoring existing code bases for the most part. That will begin to change, but that's a harder problem. But anyway, this was a natural place to start. Now, as we're going to explain, it's a lot harder to translate the progress in this domain into other domains outside software and math, as we're going to explain.
Yeah, so let's look deeper into why software engineering and math are such good examples. So the chart here, it tracks accuracy in a basket of reasoning benchmarks. So you got grade school math, competitive math, you got the SWE suite, et cetera, over 5 years. So the y-axis is the benchmark accuracy, the x-axis is the calendar year, and you can see everything's kind of meandering upward until late 2023, and then the red box shows this near vertical surge. So what changed? Post-training reinforcement learning on top of an already strong model. So why does it pop first in software engineering and math? You kind of explained that, but give us a little bit more color on that, George.
Okay, so the key is the data efficiency in the pre-training era, which is, essentially up through 2020, partway into 2024. The data efficiency isn't that great. That's where we were mining essentially all those wells of free data on the internet. But then we went into the post-training era where we're using trial and error or reinforcement learning. But for that to work, the model needs to be able to check its output and learn from whether it got it right or wrong. And when that regime started working sometime in late 2024, that's when we started seeing the math and coding benchmarks shoot up almost vertically. That is the post-training era kicking off. That's what's critical. Now, it has not yet generalized to other domains. Now, there's two other areas it could generalize to. One, things that are not easily verifiable. And that's when you need like another LLM to judge the output and say, does this look right? Or do the aspects of the different aspects of the answer look correct, and give feedback that way? That's harder. But then there's the version where you do find other verifiable domains, which we're going to get into, the digital twin, where you can make equally rapid progress.
Yeah, so, and you called this out in the previous chart, this recipe doesn't generalize to supply chain or reasoning or financial forecasting, where things are fuzzier, and there's maybe more human judgment. But the point is, software engineering is the new wave beyond consumer agents. And so once you inject reinforcement learning into a reliable reward signal, you're seeing that's why it went exponential. Now here we see in the y-axis it plots the task length. So think that as, like, if I understand it, George, wall clock work that a human would need, the time a human would need, and then this sort of gently sloping green 7-month cadence it's well overshadowed by the blue trend line on the right, which halves the time horizon every 70 days. So on the left, you've got general agent benchmarks and the length of the task that AI can complete without human handholding. It doubles roughly every 7 months. So GPT-2 could to answer a trivia question. GPT-4o could spend 10 minutes, 15 minutes optimizing for developing a chip or something like that. On the right, and you've given Scott Wu of Cognition sort of credit for this, you got the software engineering agents. The doubling time, you were explaining this to me last night, it's not 7 months, it's like 70 days. So you got Claude, you got GPT-4 variants, they're blowing through the SWE benchmarks. Connect the dots for us. Why is coding experienced this 70-day Moore's Law on steroids, and what has to happen in data and tooling and organizational change before we can see similar curves in some of these other generalized domains?
So this distills really in a microcosm the challenge of training an agent to get better over time on the left when it's just general purpose tasks and it's harder to give feedback. This is where you need to do evals or whether you're just riding the general improvement in the underlying pre-trained models. That's the every 7 months. But when you can get this reinforcement learning with a verifiable reward, meaning does it pass the test? You know, whatever other signals you can give a software development agent, that's why it's improving instead of every 7 months, but every 70 days in terms of doubling. And the measure here is it's the task complexity or the length of time that the agent can run autonomously before it needs human feedback. So we should just leave it at that, which is the slope of the improvement is very dramatic when the agent can get a hard signal about whether it's doing the right thing.
So
That's the key point.
let's explore this further because it's really eye-opening. You know, meaning the brutal economics underneath the whole rise of agentic. So in this chart, the y-axis is the composite benchmark score, and then each colored step represents a new model release. And then the dotted red box, it shows OpenAI, it's a leading model, which itself changes that large gap, and then the quick catch-ups by rivals, that's short period. So that stair-stepping chart shows the independent AI intelligence index for frontier models from OpenAI, Anthropic, Google, Meta, DeepSeek, Alibaba, and others over the past 24 months. So the vertical jump, that's the red, you have listed here as CAG, that stands for competitive advantage gap, so how far a release leaps ahead of the pack. And then the horizontal line shows the CAP, the competitive advantage period, meaning how long that lead lasts before a rival catches up. And so what stands out is how small both dimensions have become. So 4.0 takes the lead, but then within weeks we see DeepSeek, Gemini closing the gaps, and the switching costs between APIs are, not a few lines of code. It's nothing. So the cap shortens with every release. In other words, you could spend $1 billion on compute and data and only have like a 6-week pricing umbrella before the market
and that
collapses.
becomes problematic. Yes, when you spend $10 billion on and a couple years on the run, and this is then your differentiation lasts as long as like your new model Sony Walkman or whatever.
I mean, it's not like the
Yes.
pharmaceutical industry, right? In pharma, you get a decade of patent protection, 10, 12
Yes.
years. It's this is a whole different model and not enticing, frankly.
But this is because it's making our point, which is they're competing on compute advances in terms of like bigger and bigger training runs, algorithmic advances. But the algorithmic advances diffuse in terms of knowledge throughout the community. It's hard to lock them up for a durable, period of time. The compute advances really are to whoever, can build the biggest cluster. And there is some, proprietary training data in there, but again, it's not the entire recipe. If you want a large competitive advantage gap and a durable competitive advantage period, that's when you're going to need something completely different. That's where we're saying you're going to need an entirely different data foundation, which we're going to get to.
Well, and so let's take a look at how this whole dynamic shows up in pricing models. It's really killer. So take a look at this graphic. The x-axis goes from October 21 to April 25, and then each diagonal line shows successive model releases driving price down like an order of magnitude every few months. So it's US dollars per million tokens against the release dates. So all the colored trend line is a different capability. 3.5 is the teal. You got GPT-4 in the pink, 4.0 in the blue. Irrespective of the tier, the prices decline on an exponential path down. I mean, it's just 900x, even The slowest slope is 9x annually. So you, to your point, you can burn 10 billion on GPT-6 training, and then the market reprices that output at a fraction, maybe 1/10 of the margin in a single quarter, and without the switching costs that we talked about. So how do model vendors, George, justify this 10 to $50 billion capex when the price curve looks like this?
Well, this is, I think the point to make here that the accelerating pricing collapse on the APIs, this is different from the products that you build on top. But the APIs, I think it's because the amount of VC money going into these frontier labs is accelerating. There are countries now ponying up money either to build their own models or like a growing number of Chinese labs or like Elon Musk trying to get in the game. The old joke about what's the difference between Larry Ellison and God is God doesn't think he's Larry Ellison. And now it's what's the difference between Elon Musk and God, and God doesn't think he's Elon Musk. And he's trying to chase this, and he has neither distribution for his API nor distribution for any product that's coming on top. The point is, just like in the internet bubble, there's tons of money, tens of billions of dollars pouring into what's essentially chasing a mirage, where we've already got the leader in the consumer agent, and we've got, or at least one, we've got a leader in the API area, which is Anthropic, but lasting differentiation literally lies in doing something differentiated, and that's what's going to bring us to the next era.
Well, let's come back to the eras, the three eras in AI. We kind of come full circle here. You got consumer chatbots, got us all started, and then you got coding agents in the next era, which has kind of created a bit of a flywheel for companies like Anthropic. But enterprise agents are where we think the real money is, and will, to your point, build a long-term moat. So you got this trajectory in three discrete eras, which mapping on the curves here that we're showing: pre-training, post-training, which is kind of coding, and then the digital twin era. That's really the heart of this episode. George, can you explain in more detail this third era and the feedback signal that's going to come from a live digital representation of an enterprise, and what an enterprise AGI is actually going to look like? We'll get into that in a moment, but double click on that third era.
I think if there's one thing that you take away from this whole presentation is AI is programmed by data, and true durable differentiation is going to come from proprietary data. And just like we showed, like back in the November, the original broadcast about why Jamie Dimon is Sam Altman's biggest competitor. What we've learned since, we said at the time that JPMC, and as a proxy for any advanced enterprise, they have, we thought at the time, I think 150 petabytes of proprietary data, and GPT-4 class models are trained at somewhere around a half petabyte to maybe a petabyte, and that number may be larger now for the next generation of models. But we've also heard since that JPMorgan class companies might have an exabyte of private data. What we didn't do a good job explaining then is it's not just the volume of the data, it's how the data is modeled to represent the operation of the company. In other words, it is really dense, high signal data. And it's not only the data, but we're going to have to make changes around the models. For instance, enterprises and their application vendors, they're going to have to learn how to master reinforcement learning. This is the trial and error learning and continual learning. And this new data infrastructure, when we talk about the digital twin, we're not talking about a data lake. We're talking about something that tracks people, places, things, and activities, processes. That's an entirely different process-centric model that knocks down essentially 60 years of application and data silos. And finally, and this is the biggest thing that's probably, I believe, may have to change even which model vendors can support these efforts. But it appears that this reinforcement learning works best when you have open weight models. And that appears to be incompatible with the business models of the frontier labs. And from what little we can hear, that might be what Mira Murati's Thinking Machines is aspiring to do. In other words, this is going to create an entirely new set of go-to-market motions, a new set of application platform companies, and a new technical infrastructure. And as we're going to explore, new organizational model and ultimately new business model among the companies that adopt this.
So you may be wondering, if you're watching this episode, what does this whole thing of enterprise AGI look like? So maybe we can dig into that. We've kind of hit the punchline of this episode. We're all obsessing, and George, you shared this, that this is kind of the standard way in which people think about agents, with the boxes in the agent stack, the short-term memory, the planning, the reflection tools, but the piece on the bottom, that gold strip, that real-world model, is this live digital twin of a business that feeds the agents and rewards them. In other words, the data just doesn't inform the agent, as you said before, it programs it. So explain this concept in more detail. Why is the digital twin data layer the real frontier for enterprise agents, and what skills and architectures are needed to build it? How does shifting focus from algorithms to data end up determining how enterprises can actually take advantage of this next phase of AI?
Well, the first thing we should point out is that this diagram of like what is an agent, where on the left you've got tools, and then the type of tools they list: calendar, calculator, code interpreter, search. Then on the right there's planning, reflection, self-critique, chain of thoughts, sub-goal decomposition. And then on the top there's the different types of memory. Then on the bottom there's action. It's all about the algorithm. Like this is what computer science researchers are always focused on. The data is boring. The data is not what you get rewarded for in terms of, making big advances. But in the enterprise, it's all about the data. I lifted this diagram from, I've seen it in many places. I lifted it from a lecture, a recent lecture at Stanford Computer Science Department. And the guy left out where all the value is, which is what in an agent is called the environment or the world model, because the agent interacts with an environment, and based on the outcome of its interaction, that's the signal that allows it to learn. But it's like an afterthought for most people who focus on these He-Man advances in algorithmically. And the reason there's no focus on data is why we think the disruption of enterprise agents is staring us all in the face, and very few people are talking about it.
So, maybe we can pull some examples from real world models where agents got started, and really gaming is kind of that first example. This 4D map of the enterprise is something that we've seen before. So George, I want you to explain this, and Ken, if you can sort of bring up the model here. You've got Alpha Star battle. I don't know if you're a gamer. I'm not a gamer, but every position, so each Protoss here is a thing. The position is a place. The build order is an activity or a process, and the opponent is a person. So that's people, places, things, activities, that 4D model. And then you show the matchmaking rating, the MMR, on the right-hand side. And the blue curve is the human progression, and the red dot is where Alpha Star just blows through the top decile, I guess. So what can we learn from this, George? What's the takeaway?
So you hit on the key thing, which is you mapped the people, places, things, and activities that are in the game to what we've been calling the 4D map, which is people, places, things, and processes in a business. That's why the typical data platforms we have today, they're just snapshots. That's like looking through a kaleidoscope. You need something much richer that gives you the dynamics, because when an agent does something in the world, it needs to get feedback from the outcomes of its actions. And that means it needs that 4D map to say, well, if I did something to this person in this process, it ripples through to these other people in these other processes. And reinforcement learning, this is where it first took off, because they had these world models in the form of, in this case, it was StarCraft, and the paper was AlphaStar, and this was from DeepMind, and OpenAI had something similar with Dota, another strategy game. But the point was, it gave a chance to use reinforcement learning, where the verifiable reward was, how is your strategy compared to how is your strategy compared to other players, and how is the ultimate outcome, which is did you win or lose? But they're intermediate rewards. And the point is, that's where agents first took off. And as we'll see, we're going to be able to take lessons from this and a more advanced version, and then apply that to how the enterprise is going to look.
Okay, and that example is a Minecraft example. Ken, bring up the next slide. George, this is the Minecraft situation. How is this additive to what we just talked about, and how does this inject skills into the model?
Okay, so this here is Minecraft is the world model. It's another game. This is actually probably even more well known. And the project was Voyager. And the example here is, it was more open-ended, where the agent learned progressively how to make tools, and then how to use tools to accomplish tasks. And it might learn a stone tool, and then it might be able to build some structure with that, might then learn a more sophisticated tool. And the idea was, over time, it learned these skills. And the skills, as we're going to see, were very important, because it was learning new tools and learning new skills. And that was ultimately building, as we're going to see, a richer world for it to interact with. That's a key learning that we're going to apply in our enterprise world model.
All right, we got a lot of ground to cover, and we're running out of time here. But so I want to double down on the importance of data. You know, all the headlines, they credit the algorithm, and this slide here sort of takes you through sort of the algo, but more importantly, George, the data set that led to that. So you're showing here, you know, AlexNet and ImageNet was the sort of data set, and then the web was the data set for transformers, and then the reward model was sort of the human ranked responses were the data set, and now we're talking about digital twins. And so, George, this last row really frames the premise of today's discussion nicely, doesn't it?
Yeah, and it also highlights yet again that no one's paying attention to the data set that's staring us in the face. This was from a well-known blog post that was recent from Jack Morris, and he was hosted on the Latent Space podcast. And he highlights that in the reasoning era, agents are going to need this new data set. And he almost like left it blank, where he's like, oh, we're going to learn from verifiers like calculators for math, and compilers and unit tests for code. And I'm like this is staring everyone in the face again, which is the data set that we are preparing, that is immense, is where every organization is going to have a platform that is essentially a a digital twin of bigger and bigger parts of their business. That is the data set that's going to power the enterprise reasoning era.
All right, so we moved up the curve from consumer chat to coding and software engineering, and this slide shows how it all works inside a company. The chart's from Palantir, and at the bottom right, you got the end-to-end supply chain. The red callouts in the left highlight the RL feedback arrows, which feed the agent box, and the metrics tree fits in here, which sets up, not only what happened, but what should we do next? What happened, why it happened, but really importantly, what should we do next? So this is a world model, George. It's live, it's organic, it's a digital twin as we're defining it. Again, not Jensen's Omniverse, but a digital representation of an enterprise. And this example, it maps everything, that every order, every truck, every policy, all the machines, et cetera. So, how should we think about this manifesting itself in terms of actual real world work?
Okay, so it's one thing to just put up this digital twin. In this case, it's a Palantir picture of how an enterprise works, and say, well, that's, plug that in instead of the game world. But the mechanism that allows us to map agent actions to the outcome of their actions are the metrics, and the tree of metrics. This is not like the metrics that you have in your basic business intelligence dashboards. Here, the metrics are all linked in a giant tree. It's really a graph, but it's easier to show as a tree. And that means, like, when you change one thing, for instance, like if you want to have a customer be able to return a product, you want to see satisfying that customer support incident, you might also see it ripple through to its impact on, say, allowing it to return, and that adds to inventory. And then there's money that has to flow out. And it's the metric tree that learns how all the metrics are related to each other from the digital twin. It's not like the metrics in your BI dashboards. Those, if they're related at all, it's by these hand-coded formulas. Here, the metric tree is a learned set of relationships. And so when an agent does something, it really learns how its actions ripple through to other actions. And that's why the fidelity of your digital twin is reflected in the quality of your metric tree. And then when an agent does something, it learns that it has ripple effects on other metrics. And then when we show this, again, this agent diagram above the world model, we're saying, now forget about those tools that said, oh, we had a calculator or a code interpreter. Now the tools are, I want to execute a SQL query, or I want to run the business rules to see what does this data mean, or I want to do graph reasoning. Those tools correspond to the metric tree questions. Like when you want to know what happened, that's like SQL. When you want to know why, that's the business rules and the graph reasoning. What's likely to happen, that's the predictive ML. When you want to know what should we do, that's prescriptive ML. Those tools need to be invoked dynamically so that if there's a metric that's not in the tree, then that becomes, like we saw in that Minecraft Voyager game, that becomes a new tool, and then that can become, the result of the process can become a new skill. And the skill then goes back into the digital twin and helps build it out. This is why the digital twin doesn't have to be fully built out in advance. It's an iterative process between the agent and the underlying, essentially symbolic representation. The two interact with each other and get richer over time. It's that feedback loop that is so critical.
All right, and let's tie this into the concepts that we've applied in many of our breaking analysis and how it's going to impact enterprise architecture. So this graphic builds on something that viewers of breaking analysis have seen before, and also your services as software podcasts. And so the purple band is that system of engagement where we show a bunch of BI players that are going to have to insert business context into the system via the metrics and the dimensions that you were talking about. You can see the vendors there. The green band is the most important piece of real estate in our view, the system of intelligence. That's the digital twin, and we show a short list of vendors that are vying for that 4D map. And then whoever hardwires that business logic and skills into that layer becomes a really important player here. The yellow band is the system of agency. So once the twin is in place, agents invoke it for answers and route write-backs into that system through the digital twin, guarantees that every action lands inside a governed policy, which is shown in the orange. The blue base is essentially data infrastructure. We got Snowflake, Databricks, we could add hyperscalers there. It's really important infrastructure, but we're going to see margin pressures there, we think, as the green and yellow layers climb in value. Unless, I guess, the hyperscalers, we talked about this, George, set, AWS in particular, sets an umbrella, but lay out the battlefield for us, which vendor type, the archetype of the vendor is a data platform, the pure play, process mining. We've got SaaS vendors in here, we got incumbents, we've got knowledge graph upstarts. It's really jump ball, isn't it?
Yeah, but it's, this is the history of IT where you have layer on layer of abstraction, and it doesn't invalidate what comes before, but if you envelop it with a new platform, then there's the risk that the layers below, the risk that they lose the ability to differentiate through features, and then they lose some of their pricing power. That's the risk. It doesn't mean that they can't continue to innovate, but then the vendors above are the ones who choose which of those features to adopt. Now, the reason we're calling out the system of intelligence in green as a completely new layer is that traditional data platforms were snapshots of strings, and they're up-leveling that to snapshots of things with metrics. But the green layer adds not just things, but processes. And that's profoundly different, because that's where you stretch across all the 60 years of islands of applications and data that we've been building. So to walk through some of the vendors, Palantir, they have a very rich ontology. I call them the Sean Penn of vendors. As this is Sean Penn in Fast Times at Ridgemont High when he says, I've got the ultimate set of tools, I can fix it. It's not easy to build on it, but it's super powerful. Celonis, this is process intelligence, which captures not just this idealized state of how things should work, which is how applications have traditionally been built, but they capture the as is, all the thousands of variants for how a process works, and then show you how you can optimize that. And that is getting built out in a packaged way so that the difficulty, you don't have to hand build every process. It comes sort of prepackaged. Similarly, Blue Yonder builds out a supply chain model. Salesforce, as we've highlighted on the show many times, has all the customer processes, not just the customer profile, but the engagement model. And as we've also noted, their ambition is to go well beyond that. That's why they're buying Informatica. Relational AI, the first knowledge graph platform that aspires to spreadsheet level accessibility. In other words, because it has this declarative programming model, it's much, much easier for business users to participate in defining the business logic. Doesn't mean they write it themselves, but they can participate in it. ServiceNow is building the workflow data fabric, also a process-oriented model. And one last thing to point out, Databricks, as we've said when we recapped the Databricks summit this year, the CEO said data intelligence for them is existential. And I believe he means, and he's sort of said, they intend to go beyond just metrics and dimensions, which is what the data platforms do today. And he talked about customer data platform, security, observability, but that's all in the future. That hasn't started yet. And they're like unbelievably advanced agent development tools are going to need that more advanced data intelligence, or they're going to need to plug into one of these other vendors to get the value of their process knowledge, which is not yet in Databricks.
All right, let's simplify things and talk about how enterprise software is basically splitting into two worlds. We're going to use our James Bond metaphor. We've used this before. It's classic scene in a frozen lake. Above the ice, that's the yellow-green territory that we just talked about. Systems of engagement, intelligence, and agency. You're learning from the business and the digital twin. And then below the ice, it's all the infrastructure, the data, the platforms, the storage, the models, the GPUs, and pricing, ostensibly will collapse unless you've got a monopoly like Intel had, and like, it looks like NVIDIA, is building. The hyperscalers could keep, as we said, artificial umbrella pricing over spot instances. But, history says that eventually that comes under pressure, but, the visual drives it home. Bond is up safe on top of the ice, and the below the ice is a hairy place. It's a schlocky business. So what moves do people have to make real quick? And then we got one more concept to show.
Although I should point out, Dave, since I was making the movie analogies, that actually wasn't Bond. That was the villain. That was Rami Malek. But the point was that the whole industry is sorting into vendors who are above the ice, who learn the business from modeled data. And if you are above the ice, you can move towards outcome-based pricing. You have higher value differentiation. And in fact, some of that value is ultimately going to be captured, probably the lion's share, by the enterprises themselves. But vendors who enable their customers to learn can also participate in something approaching outcome-based pricing. If you're at the data layer or below, you're probably facing utility pricing. And it doesn't mean you completely get commoditized, but it's harder to differentiate.
All right, so we've come full circle. It's all about enterprises. Let me just bring us home that own the data and can apply AI to leverage that data in a differentiable and sustainable way. The bottom line, in our view, is enterprises that build a digital twin with coherent data representing their enterprises are going to be in a better position to reap the profits of AI. We spent the better part of the last hour tracking how the balance of power is shifting from labs that train frontier models to enterprises that own the ground truth data. Those models now require to survive, and this closing visual kind of makes the point explicit. You got Sam Altman, world's most famous foundation model. You got Dario Amodi in the middle, showing post-training can mint, strong ARR, but the center right, the Holy Grail itself, represents a live, verifiable digital twin of the business, or AGI, if you like, if you're the consumer guys. And on the right is Jamie Dimon sitting on the richest transaction ledger in finance. He could become the first CEO to weaponize that digital twin and challenge the model labs on a margin and moat basis. And George could show the enterprise the way to new riches. Your final thoughts, please, make it quick.
Okay, the one thing to take away is it's not just a technology problem. In other words, it's not just that Jamie Dimon has, or advanced companies like him need to build a digital twin. They will need to adopt new organizational models designed around end-to-end outcomes, customer outcomes, like in the case of a bank, like how fast can you onboard and know a new customer? When you say know a customer, that's for compliance reasons. So it's equivalent to moving from craft production with white collar work to an assembly line with white collar work. And I will just say that if you want to explore more about the organizational and business model implications for the customers, we have we have an interview with Karsten Thoma, the president of Celonis, that we will drop in the with a link to at the end of this and publish alongside this.
All right. Thank you, George. That's it for now. Thanks to Alex Meyerson and Ken Schiffman on production. In our podcast, Kristen Martin and Cheryl Knight help get the word out on social media and our newsletters, and Rob Hof is our EIC over at siliconangle.com. You can check out these episodes. They're available as podcasts wherever you listen. Just search Breaking Analysis Podcast. We publish each week on thecuberesearch.com and siliconangle.com. You want to get in touch? Email david.vellante at siliconangle.com, DM me at dvellante, or comment on our LinkedIn post. And check out etr.ai. They weren't featured in today's episode, but they often are. They get the best survey data in the business. This is Dave Vellante for George Gilbert and theCUBE Research Insights, powered by ETR. Thanks for watching, everybody, and we'll see you next time on Breaking Analysis.